All right, hello everyone. It's December 15th. Today I went to the library. I put a book on hold, which is by Harry Frankfurt, who wrote a book called On Bullshit. I think it was in an article of his back in 1985, but later on published as a tiny, tiny booklet in 2005. It was fun. So I want to just take a look at that book. I mean, the reason I was interested in it is because the popularity, the buzz these days around Chat GPT, and actually just all these language models. I mean, we all know how they're made. They just basically take in all the corpus of words that humans have spoken, have written down online in the library, whatever, and they have a giant language model, billions of tokens, and then they just mimic. They mimic how human beings construct words to put them into sentences and paragraphs. And basically, what ChatGPT does is bullshit. I mean, it's not lying, it's not doing anything with any intention. It just mimic how human beings put words together and then give it a prompt with certain words in it and then just try to find a way to weave those patterns, those prompt pattern into its response by taking words and patterns from the corpus, and then it creates a paragraph. I mean, honestly, I haven't tried it myself, but from all the sources I've read, its response is uncanny, and it's so good. The ability for it to generate very human-like this thing passes the Turing test for sure. It passes Turing test, but again, it kind of shows the insufficiency of Turing test. It cannot test the quote unquote intelligence of a machine just by Turing test because it can just mimic human beings so well, so well. And not only that, I mean, the examples I saw all also presented ChatGPT's ability to understand context. Well, I should put a quote on understand as well, but it remembers, right? You can really strike a conversation, and as you keep going on, whatever have been discussed before will be reflected in the future. You can ask it to do one task, and then you can ask it to do another task similar to the first one, but without telling it again what the first task was. You can just say, okay, I wanted to do another thing which is similar to what we just talked about, and then we'll just do it, which means it remembers the flow of the conversation and everything that's been discussed before. It was remarkable. Very, very. I was stunned. But it's bullshitting. No, it doesn't understand. You can ask a question and you can tweak your prompt however you want, and it can lead the answer towards those directions. So it doesn't have any understanding of the things that you're actually trying to ask. So, and then I read that there is a booklet called On Bullshit. So I took it from the library. It was good. Right. I mean, I haven't read it, but it was interesting that they have a booklet like that. But the more important thing is the serendipity of the experience going to the library. I mean, you go inside. I picked the book, right? It was on hold, so it was on the shelf specifically for pickup. But then, as people always do, you go to the library. You don't just go in and go out. It's not like a takeout restaurant. You go in and you try to just walk from aisle to aisle, and then that's where serendipity just kicks in. All right, you go to the aisle. There are like hundreds and hundreds of books there, and you don't know which one you like. You don't know which one you want to check out. You just start reading the titles. I mean, you don't even know. You just go in, and the titles are all tilted, right? So you tilt your head, right? You go in and read all the titles, and then suddenly, hey, I think I remember this author, or suddenly, oh, wait a minute, I think that title, I've recognized that title. And that discovery, this serendipity of discovering things that you might have heard before, or some title just like, I never realized I might have interest in in fungus. There's just a book about fungus. And then just this experience is so good. It kind of, it pull you back from what the current society, or current what we've experienced with everything just on demand, right? Everything is being fed to you. Everything is going to get easier and easier. The discovery of content is easier, right? TikTok, you don't even have to discover yourself. Everything's fed to you. It's a complete difference, complete opposite of that. In the library, you have to search. I mean, you can search online, but the experience of going inside with no purpose, with no target, you just look through everything. And you know what I found? I found the other book by uh, by Harry Frankfurt. It was called On Truth. I mean, I vaguely remember from reading on Wikipedia that he had a On Bullshit first, but then a few years later he completed another article called On Truth and then published it in the same style. These are very tiny booklet, like not even 100 pages, big font, huge margins. So it will take like hours, a few hours. You can read both. But this discovery experience, it was so good. You know, it kind of reminds the quote unquote good old days. I mean, what is this good old days? It's just good things need to be discovered. They need efforts. It's like the ancestors, right? Hunter gatherers. Nothing is easy, right? You grow stuff, nothing is easy. You hunt stuff, nothing is easy. And then you treasure them once you find them, right? When you find a book, it's like treasure hunt, and then you treasure it. You value it. You read through it. You gather the information. You get more out of it compared to you just, you know, sit there with your phone and then having the algorithm feed you stuff, or audiobooks. I mean, I still have this this thing against audiobooks. I mean, is it efficient? Oh, God, yeah. I mean, I've used it driving. And you hear the audiobooks, but it's just different because they're fed to you, right? Somebody's reading it to you. But content, these things, you have to go through the trouble, go through the effort, to read it, to absorb it on your own in order to really internalize it as yourself. At least it's my view. So I stay away from audiobooks because I want the voice to be my voice, the inner voice to be mine. I don't want any acting, any other people's input to influence how I will interpret and experience the things in the books. So yeah, that was a very good experience. I mean, I regret to say that I didn't visit the library often enough, but every time I did go, it's always a blast. And they have lots of math books. I was surprised. There's one book it's a workbook. It's a 320 problems from the Soviet era when they were training their Olympiad team. So it was just questions from the number theories and all that. I mean, I just flipped through, I found a question saying prove that there are infinite numbers of prime numbers. And I was just standing there and think about, wow, how would you prove that? And then, I mean, it's not a difficult proof, but yeah, there are treasures. There are treasures in the library. All right, anyway, let's go into today's challenge. Implement a queue using stacks. All right, this is a old problem, not old, classic problem. So we need to implement a queue using two stacks. Push, pop, peek, empty. Use stack, only push to pop. Yeah, I kind of know how this wants. 100 calls. Amortize to 01. Let's not think about that. Okay, so two stack, right? We solved this before. At least if not in LeetCode, let's solve it in the class as well. So a stack, you just push and pop, right? So it doesn't work. One stack definitely not work. But if you have two stacks, so what you want is just to put the front of the stack on one stack and make it to be the back of the other stack. So you push. When you pop, oh yeah, you just move. Let's say you just move all the value from the first stack to the second stack. Right? You push from the first, you You pop from the first, you push to the second, and you go you pop everything from the first, you push to the second, then the first in will be the top of the stack on the second stack. Then you can pop there. You always you can do this. You push to the first stack and you pop from the second stack. That's it. But when do we do this transition? If you just push, we don't transit, right? If you just push to the first, and whenever you pop or you peek, then you do the operation. Yeah, you push, we don't care. Push, we only push the first. We don't care. And if we pop or peek, what does peek do? Returns the element at the front of the, so pop or peek, you have to go to the second. And then empty is just the length of the two has to be 0 for it to be empty. Okay. We got this. I mean, it's an easy problem anyway, so shouldn't be any challenge. Well, does this count as amortized O1? Yeah, I don't know. Let's see the answer. Maybe it does. Anyway, self.s1, okay? We call it stack 1, stack 2. Push. That's it. Pop. While self.s1, self.s2.append, self.s1.pop. And then return self.s2.pop. Peek while self.s1, self.s2. Wait, hold on. Do we do that? No, we don't do that. You push, right? And you pop. You want to pop, you have to do this. But then you push it again. Then you want to pop again. No. Pop, we should say, if self.s2, then return self. If not self.s2. Right? It's only if self.s2 is all empty, that means the front of the stack, front of the queue is on S1. So we say if not S2, then we need to push this in, right? What if it's empty? Removes the element from the front of the queue and returns it. Yeah, what's the operation if it's empty? All calls are valid, so you don't have to worry about that. So peek is the same. Oh, maybe this is what we can do. We put this into peek, and this will return self.s2 minus 1, the top of this. And then we can call self.peek, right? And then we call this, because this will be the same thing. Empty will be return len self.s1 plus len self.s2 is equal to 0. If it's equal to 0, that means it's empty. All right, we don't have to test. Let's go try it here. I think it should be right. Wow, we haven't done this before. We've done it, but I mean, this is ON, right? So I'm not sure if amortized every operation. What's it want every operation to be O1? I mean, pop and peek is not O1. Pop and peak are not O1. Oh, Jesus. All right, how do we do? Push ON, pop O1. Push O1, pop amortized O1. Oh, yeah. Yeah, we have to do this. So this is amortized O1. All right, I never really understand amortized, but actually this is, but amortized O1. I never know. I never really read this. Average performance of each operation, the worst case. A worst case operation can alter the state in such a way that the worst case cannot occur again for a long time, thus amortizing its cost. Oh, so if the worst case cannot, or we put it this way, if we have a worst case, right? If we have a worst case, then after the worst case is over, it will not persist. If it does not persist, then we can say amortize is not ON, but O. Like in here, the worst case is if we have S2 is empty and we have something in S1, right? When that happens, which means we do a lot of push and then we pop or we peak, then we have to move everything from the first stack to the second stack. That's ON for sure. But once the situation happens, the worst case does not happen again until the second stack is completely consumed. So that's what it means. Can alter state in such a way that the worst case cannot occur again for a long time, thus amortizing its cost. Yeah, so whatever the cost is will be amortized over time. Yes, if you push n times and pop n times. Worst case time for a single pop is ON. Yeah. Per operation will be ON squared. However, that's true. In the sequence operation, the worst case does not occur often. Yeah, it only occurs once. Yeah, it's a passive bound. Only some inserts take a linear time. I mean, in my case, some pop takes linear time. Yeah, it's 2n because you do pop operation can be called limited by the number of push. Yeah. N push plus 2n for first pop plus n minus 1 for the pop operation. Yes. How do you get 2 times n? We have n, we have 2n, that's 4n. 4n minus 1. I mean, it is O2n. Makes sense. Okay. Yeah, but it makes sense. No, it's not weird at all. It's a good problem. It's a very good problem. I mean, we learned amortize. I mean, I've heard of this many times in the past, but I never really know. I kind of know, right? It's like average performance, but this is more clear, right? It's just the worst case scenario cannot happen. Let's just put it this way: the worst case scenario cannot happen consecutively, or cannot happen too many times. Or if you have a worst case scenario, then you have a long stretch of best case scenario, and then you can amortize. Yeah, I'm basically just saying it is the average performance. It is the average performance. And because the worst case doesn't happen all the time, then when you average everything, it's amortized. Okay. All right, back to the struggle. Man, this problem is just... I tried 2 solutions, didn't work. Yeah, I'm saying I'm gonna go for the hints. All right, what do we have? How can we check which indices of nums1 will be considered for swapping? How to minimize the number of such operations? Well, which indices will be considered for swapping? Now we have to compare everything, right? We have a way, like if the nums1, nums2, they're the same, yeah, then they have to be swapped. But if they're not the same, then we don't have to swap them. And we want to minimize the number of swap. For sure, we want to minimize the number of swap, which means if we can swap the 2, because my original idea is we swap with 0, and then we can save time. I save the cost. But another way to think is if we can pair, right? If we can pair, and that, yeah, because if you think about it, all the values, all the numbers that match between nums1 and nums2, all of them has to be swapped. So their indices must be added, right? That's like the hard, like the minimum, like the bare minimum. The best situation you have is you have even number of matches and they can all swap with each other. So the cost is just the sum of their indices. That's the best scenario. So at the beginning, yes, you should try to see if there exists pairings, right? If we have pairings, then those can just pair and then we just swap them and then we don't have to worry about them again. And the difficulty is when you cannot pair, all right? And then we say to swap, you have to be, these 2 values has to be different. The value to be swapped have to be different. And wait, hold on. We can always swap. We can always swap. Yeah, because we have nums1i equals nums1j. We have nums1i equals nums2i. nums1j equals nums2j. So in this situation, as long as nums1i and nums1j are not the same, they can always swap. So basically, we can go through everything and find out which ones need to be swapped. So we get the indices of which one need to be swapped. And we need to know if any of them has repeats, right? So I say, I don't know, we can go through all of them and then we record the values and their indices that they occur that need to be swapped, right? Okay, so we have these values, we come out, and then we can do what? So every pair, right? Every pair, so if we sort them, which will be sorted from small to large, so we can get just a pair, and then boom, that's gone. And then move on to the next one, and then, because they're all smallest, if we sort it, and then we do another pair, so eventually we have some left. Yeah, eventually we'll have some left, all right? let's say either we have one value, right? Because it's not even, it's odd numbers. So we have one value left, and when that value is left, then we just check from the beginning, right? We try to swap with the smallest, see if we can swap. Okay, what if we have multiple values? Well, if we have multiple values, they can always swap with each other. That is correct. They can always swap with, if we have two values that need to be swapped and they are different, then we can definitely swap them and be done with it, right? So the only case that eventually will end is we have one value, we have multiple repeats of one value, one or more repeats of one value. And for that, we just simply have to run through everything. I mean, there's just no way that we can avoid it. We just go through everything, match one, there's a swap, and then go to the second one. Let's try this idea. So what we need is a default dict. I feel like I should be able to think about this, come up at least this solution. I'm not sure it's gonna work, but I do think I shall be able to come up with this myself. So it's a little bit embarrassing that I wasn't able to. So anyway, so what we do is we say, let's just delete everything. If n is equal to nums 2i, right? That means this one needs to be handled. And we say indices n dot append I, right? So boom, when we're done, then we go through all the keys of the indices. As long as these two are different, they can be swapped. And then we go from front to end. What do? We need, it will be easier to use a deck. We either use a deck or we use, we pop. Let's use a deck. Right, deck is here as well. Man, that'll be interesting. Deck. Does that work? I don't know. We'll run it. Oh man, it does work. All right, so deck will push, push to the end, and the deck is already sorted. And then what we need to do is to get any pair, right? Because to the front, we have to do all of them, no matter what. So say rest equals 0. And then what? How do we do all the pairs? We can go the first two once we're done. And then, How do we handle this? We have all the keys, right? So we can get the keys out. Okay, we can loop through the keys. And we have the second key. So we have two pointer. I can make 2 pointer pointing to 2 keys. And then we can go from both and coming in because it's the same. So we can have a list of keys, and then we have 2 pointers, one on the left and one on the right, and they try to match. Whenever this is done, we move forward, and move in, and we move in, and move in. Something like that. Let's get it. So we have keys. I'll just call it keys. The indices dot keys. Okay. And then we say I, j equals 0 and the len keys minus 1. Okay. And we say while I is smaller than j. Okay. We say res plus equal to indices keys I dot pop left plus indices keys j dot pop left. So this will pair them, right? So we pair them together. And then if not indices keys I, which means we pop everything, then I plus equal 1. And we'll do the same thing for j. Say if not indices j, then j minus equal 1. Then we go up, go up, go up. Eventually, something will get remain, right? Something will remain. So I will equal to j. Okay, so that one is the final thing. Then for the final thing, so we say here, what we try to do is pair the numbers that need to be swapped. This way, we save the number. This way, each swap, right? Each swap handles 2 numbers, right? So we save, and then after it's done, handle the remaining numbers, remaining unswapped numbers, which are all the same, right? Which are all the same. So we have it, which is just indices keys I. Then what we need to do is just go from front to the end and then see if we can swap them, right? So we'll go from to the end, and we need to check, right, if the 2 is not the same. So we're going to say for t in range n. We'll use I again, so we use j. For I n in enumerate nums1. Oh, did you swap? Come on, man, you need to swap. Dude, this is not good. My bad, sorry. We have to record this. JJ. Yeah, we have to record this. And then this is gonna be II plus JJ, that's fine. And then nums1 II, nums1 JJ equals to nums1 JJ, nums1 II. So we have to swap, right? We swap the 2 and blah blah, that's done. And then when it come out, right? When it come out, we know the key, right? So we know I'm going to say key k is equal to keys I. It's fine. So we know the key. Now we just need to see from front to end. We say if n is not equal to k. Okay, if n is not equal to k. You know what? I don't like it. I do not like it at all. I will use t. Okay? If n is not equal to, then does that mean we can swap? Yes, it is, because everything can be swapped is already swapped. So we say if n is not equal to, then these two can swap, right? Ooh-wee. How do we swap? We will swap by, first we get II equals indices keys I dot pop left. All right. And then we will do, yeah, you know what? I feel more comfortable doing this way. T, right? So II equals this, then we say, we actually don't have to do the swap here because it doesn't affect, right? But basically we just do T and II, right? T and II, and after we're done, we have to go on, we have to move on, right? Yes, so I think we can just go res plus equal to T plus this, right? And then We go on again. We try to find the next one that we can swap. And once everything's done, we will say return res if not indices keys I. Right, just everything has been handled. Right, if everything has been handled, we say we're good. But hold on, that is actually not right, right? Because it could be something that's swapped with keys I already, right? If we have something already, let's say we have 4, and something has already swapped with 4, okay? So at the 4 position, it's something value different. Then we cannot swap, which means these two has to be different, and nums 2t has to be different from keys I, right? The num1 has to be different. That is a no-brainer, right? But nums2 has to be different as well. If nums2 is the same, then you cannot swap. So when both are different, then we can swap. And at the end, if everything, all the indices have been gone, then we can return res. Else, we need to do -1, which means we cannot handle everyone. Okay, let's try this. Oh, we got error already. Pop from empty. Ooh, wee. How? We need to check. Right? We say if not. At the very beginning, break. But then we'll go into a loop. I kind of don't want to. When I say if not, so many ifs. They all pass. We might have it, honestly. Ooh. What? How is that possible? How? List index out of range. Wait, what? That doesn't make any sense. That does make sense. That does make sense. How? Check this out. It should be 0, right? Because we don't have to do anything. There we go. Which means we have to check here, right? So blah 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 blah, and then we say if not indices, which means nothing, then we should return 0, right? Which means we have to put this one somewhere. It's a good test case. It's a very good test case. All right, try it again. Look at that. I think that is the solution. We do have more test cases. Let's try this. Ugh. Yeah. Oh, the third one is wrong. Okay, let's see. 1, 2, 3. Dude, 1, 2, 3. You wanna do 10? No, I don't wanna do 10. I wanna do 5. Let's go back to PT Python. We'll do it again. 5. That's okay. That's fine. We know the first. We just want to produce a wrong case so we can analyze. Just don't tell me it's all correct again. Oh my god. Yeah, I cannot select it. That's the thing. It's stupid. It's stupid. Yeah, I cannot do anything. Oh. Paste mode. Display. Completion prompt. Man, I don't know, man. It doesn't allow me. Now, I don't think that's the issue with tool. I think that's the issue with item 2. I don't know how to solve it. I used to be able to, you know. All right, if this is right again, we'll go back to the nah, that's right again. All right, we go back to here, the third one. All right, I think the answer is 28. No worry, it's a difficult problem. All of these are expected. This, wait, let's go 2. Oh my god, 1, 2, 3. I think answer should be 28. Yeah, I gave it 29. Double check. Let's double check this. Double check. Man, I hate it. It's just basically trial and error. Not supposed to do it this way. It's not supposed to do it this way. Alright, where is the problem? Let's write it out. What do we have? We have 1, 3, 2, 2, 2, 5, 2, 5, 1, 3. 1, 5, 5, 2, 2, 2, 2, 5, 1, 2. Okay. Let's take a look at the indices. So 1, yes. 2, we should have 2. Have 3. We have 3. 5, we have 1. Okay. So we're saying, okay, I say 1 and 5 swap. Right? So that's basically what I say. 1 and 5 swap. One and 5 swap. So 5 is here, 1 is here. 5 is here, 1 is here. That's 7. And then 1 and 2. So 8 and 3, right? 8 and 0, 1, 2, 3. So this one come here, this one come here. 8 and 3. Now we are left 4 and 6. We're left 4 and 6. So these these two cuties are left. So what we have is 18. 4 plus 6 is 10. That's 18. Oh. So we swap with this. Hold up. We swap with 0, which is exactly what we're doing, right? We swap with 0. And then we don't swap. Let's swap with the next one. Wait, hold on. Swap with 0, right? So I have 2 is here. 5 is here. So where did the last one go? Unless oh, I was wasting. I did 1 and 5. I should have matched everything in 2. Ah, I see the problem. I see the problem. The problem is I did not. I'm wasting. I could have like this because I did 1 and 5 first. So this 1 and 5 is kind of wasted, right? And now I did 8 and 3. So we have 4, 6 left. We have 4 and 6 left, which cannot be paired. But we can be paired. They shall be paired. Because this 3 can be paired with 0, 4 can be paired with 8, and then 6 can be paired with 7. So we have to sort them based on their size. And then match them. Right? Which means the smaller ones should not match themselves. So I can sort them, right? I can sort. I can dude, what do you want to do? How about this? I'm gonna sort it. Okay, I'm gonna sort it this, and the key equals lambda. Doesn't matter actually, because I'm gonna use length. Oh, and it does matter. And this is the key is k. Right, and then we say length of what? Length of indices k and minus. So I'm gonna sort it in reverse style. There we go. Now we pass. Now we pass. Wow, this is actually quite an important step. Let's check the rest. They all pass. Okay, so what do? We copy and paste everything. That is here. If they all pass, I'm gonna submit it. Oh my god. Come on. Come on. Alright, make sure we have nothing wrong with this small one. Oh god. They're all right. My problem still with this. Shoot. Now I think we're on the right track. This is the right track. We just don't know how to do it. All right, we turn it on and look for oil. A lot of errors. Not a lot. 1, 2, 3, 4, 5, 6, 7. Number 8. Number 8 and number 10. Okay. Number 8, number 10. 1, 2, Wait, hold on. 1, 2, 3, 4, 5, 6, 7, 8. So that was number 8. Nine, 10. There's a number 10. No worries. Yep, no worries. Must be something that we didn't consider. That's okay. Yeah, that's what we're here for. I mean, we're already doing this trial and error. Might as well just, stick to it. I believe we will be able to solve it. Some edge case I did not consider. Man, how are you gonna figure this out during a contest, man? Contest tough. Alright, one at a time. Okay, so I'm pretty sure that this one is correct, so we can just print on the indices. Okay. Huh. That's 11. Why did I not do 11? Oh, crap. Ah, crap. Now you gotta be kidding me. Because I'm probably just 4. Ah, crap. How are we gonna do this? Yes, sort works. Alright. So we blah 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 blah. But then, which one? Yeah, because I probably leave 4 at the end. That's why it doesn't work. So basically, basically what we're saying is we want to, the one that's left behind, right? The one that's left behind, we don't want it to be, God. We want them to be different from the second one, so I can just make the change directly. I have no idea. How do we codify this thing? So basically the things left, I want them to be different as possible from the start. Therefore, when we sort, when the length is the same, we want to sort by the difference. The difference. The difference. Nah, it didn't work. Minus. Small to large. Nah, Doesn't work. What are you trying to do? I'm trying to say after sort, I want the things like different from this to be at front. What's the keys after we sort? Oh, of course it doesn't work because I go front to back. Oh, man. That shouldn't be... But that's a 0. It shouldn't be going to the front. Wait. Oh, wait. It's going to be 4, 3, 2. Man, oh, man. Nah, that's not a way. So it should be 3 swap with 4 and 2 swap with 0. That's what should happen. How do we codify this? Or we can just say, yeah, we do the length. It's unnecessarily complicated. We'll sort. All right. But then we will take this value and this value, handle them first. And then once they're done, then the remaining can always handle with 0. Okay. But how do we... We can do a pre-step. Hold on, I will sort it, and then I will check if the 2 exists. Oh man, this is gonna be complicated. I'm gonna say if nums 1, 0 exist, put it out. If nums 2, 0 exist, put it out. Okay. Make sure we have the best chance of swapping with 0 index. Man, this feels hacking. Oh, what if they're the same value? Okay, so they must be inside this indices. I would say if nums1 0 is not equal to key 0, because if the two are the same, the key 0 will always be handled. So if they're not the same, then we just say while indices nums1 0, right? II equals indices nums1 0, top left j key 0, press and then they will swap. And we keep going until nums1 completely done. Else, if these two are not the same, then they're not the same. It could be one of them is in, or the other is in, or both are in. But this is both are in. But this is a special case, both are in. We say if nums1 0 in indices and nums2 0 in indices. So both are in, so blah blah blah, and then we say elif nums1 in indices or nums2, so one of them is indices. nums2 0 indices, then we want to handle this one as well. We want to remove them. So the 0 is always available. If both are in, then we say while 0, right? And indices nums2 0. If both exist, okay, nums1 0 and then nums2 0. Right, pop left, do this, blah blah blah. Go on, try it again until one of them exhausts. Right? Then we say if we have more of this left, and if we have more of this left. So we say both in it, right? If both in it, then we try. But both in it and these two are not the same. If they are the same, then we do one of them shall be enough. If this is in it, hold on, if this and nums1 0 is not equal to nums2 0, right? If the two are also not the same, then we swap between them, right? After we finish swapping, we'll look at, say, if nums1 is still in it, and if it's not equal to the front key, then we check. And then we say if nums2 is still in it and it's not equal to the front key, then we continue to do it. Well, I mean, we can swap with 0. What if we don't have any 0 to swap with? And we just want to get rid of this, right? We'll get rid of this, so we try to swap with key 0, but what if we don't have key 0? Man. Maybe we should just put them on the front and back. What do you think? So they'll always attach to each other? So we want to handle those two first. So we can either, if they both exist, we just put them at the two ends, right? Put them at the two ends, and then they will, once they're done, and then this will be handled, or this is done and this will be handled. If one of them, right, if one of them, so we just put it, it doesn't really matter where you put it, right? It doesn't really matter where you put it. No, it does. We want to put it at the end. And we want themselves to handle first. Otherwise, we'll put at the end. So what do we say? So we get two value out, we get remaining, and then we say if both, how about this? How about this? No, that's keys. Key in this, if key not in, key is not equal to nums1, and key is not equal to nums2. Filter it, then sorted it. That's the keys. Then we say if nums1 0 is in indices, and nums2 0 in indices, then, oh my god, you're gonna put the left and right. God. Oh man. It doesn't feel right. It's very complicated. Nope, I don't like this. I like this, but then this cannot be 0. We then have I know we can have They're the same. Now I have to go to the next one. Okay. Oh, God. Now this one is not right. The hell? Maybe this is wrong. I'll just not do this. Right, now not do this. I just break it. Okay. Do we dare? Alright, what will be the last try? If it still fail, dang, I don't even know what I do if it still fail. We try it again tomorrow. Looks promising. Do we dare? We dare. Ew. Nope. 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 All right. I'm gonna have to. Well, I mean, I only used one hint. Only used one hint, but this definitely is not working. All right, tomorrow I'm gonna use the second hint. I'll see you guys tomorrow. Adios.